Now we discussed the elasticity of the demand. This is application of the related rate problem, which is very important in your area for the business and the economic science. Okay, so when we will price increase lead to an increase in revenue? When will a price increase lead to an increase in revenue? This is an important question. To answer this question and study relationship among price, demand, and revenue, economists use notation of elasticity of demand. In this section, we define the concept of relative rate of change, percentage rate of the change, and the elasticity of the demand. To understand the importance of the elasticity of the demand, I would like to give an example. A broker is trying to sell you two stocks. Okay, one of them is the BioNTech, and the other is Comstat. So the broker estimates the BioNTech price per share will increase $2 per year over the next several years. Okay, so the claim is it increased $2, while Comstat price per share will increase only $1. But for the per share, okay, per share. In Turkish we say sheet, but this is share. Okay, that's okay. So in this sufficient information, is this information sufficient or not? So is this sufficient information for you to choose between two stocks? What other information made you request from the broker to help you decide? For example, if the price of the BioNTech is $100 and the price of the Comstat is $10, relatively when you consider, if you have $100, you can buy one share of the BioNTech, but 10 share of Comstat. So after 1 year, for each share you will earn $1. So total you will have the $10. Okay. So the price is very important of this decision. Okay. So if, for example, you have $1,000, so you have 10 share. Here you have 100 share. So after 1 year, for each share you earn $2 if the expectation is okay. Okay, so you will have extra $20. But if you take by the constant, you will have the $100. So according to this price, according to $110 price, okay, it is better to choose the constant. In other words, BioNTech's price per share is increasing at twice the rate of the Comstat's, but that does not automatically make BioNTech the better buy. The obvious information that is missing the current price of the each stock according to this example, okay? So, we introduced two new concepts, relative rate of the change and the percentage rate of the change. So definition, let's write here. So the relative rate of the change of a function f of x is derivative of the f of x over f of x. Okay, this is the relative rate of change, and if you multiply 100 you will find the percentage rate of the change. So 100 times f prime x over f of x is the percentage rate of change. And we have another alternative way form for the relative rate of the change, which is the logarithmic derivative. So this exactly equals derivative of the ln f of x with respect to x. So if you calculate this derivative, this is 1 over f of x times by the chain rule derivative of the f, which is f prime x. So derivative of the ln f of x is called the logarithmic derivative of f of x. So this is give us the relative rate of the change. Actually, in this Biontech and constant example, $2 is the change of the Biontech. Okay, this is the change of the Biontech, derivative of the, let's say, not by the b with respect to time. This is change of the constant. But this information is not enough, so you should look at the relative rate of the change. If the price is 100 of the Biontech, $2 over 100 is the relative change, which is 1 over 50. If you buy constant, the rate of the change is 1 over $10. Okay, so which one is bigger? 1 over 10 is bigger than 1 over 15. So if you choose the constant, it is better idea as an investment. Okay, in light of this viewpoint, let's continue from the elasticity of the demand. So in both part below, assume that increasing the price per unit by $1 will decrease the demand by 500 units. Okay. If your objective is to increase revenue, should you increase the price per $1 per unit? So at the current price of $8 per baseball cap, there is a demand for 6,000 caps. At the current price of $12 per baseball cap, there is a demand for 4,000 caps. When the price increase $4 here, as you see from here, it increased $4. Okay, so according to these sentences, it should be decrease 4 times 500. So this is minus 2,000. But if we look to revenue, what is the revenue? This is the demand, this is the 8. So revenue for the level $8 or okay, according to price. Okay, let's write the revenue. Just the revenue. Okay, so revenue at price is $8 is 8 times 6,000. So that is 48,000. So the revenue at the price for $12 is 12 times 4,000. So again, this is 48,000. So when does an increase in price lead to an increase in revenue or decrease in revenue? Okay, so to discuss this situation, we will need the elasticity of the demand. So definition. So economists use the concept of the elasticity of the demand to answer the question, when does an increase in price lead to an increase in revenue? Okay, so we denote by the E of P, which is minus relative rate of change of demand over relative rate of change of price. So the elasticity of the demand at price P, denoted by E of P, is the ratio of the minus relative rate of the change of the demand by relative rate of the change of the price. Okay, so this is elasticity of demand at price P. So what is the E of P? Let's calculate together. This is important. From here we will obtain very important result. Minus relative rate of the change of demand is the derivative of 2 ln f of P, because with respect to P we will focus. Okay, so actually here we said with respect to X, but this is relative rate of the change of the relative rate of the change of the F with respect to X. But here we discussed the relative rate of the change with respect to P over derivative of 2 price, which is P, ln P with respect to P. So first one is 1 over f of P times derivative of the f with respect to P. Derivative of ln P is 1 over P, and we have minus, of course. So from here we obtain this result, minus P times f prime of P over f of P. So this formula is the elasticity of the demand of the price formula. According to the value of the elasticity of the demand, okay, we will have some comments. I mean, if elasticity of the demand always is positive, okay, why? Because P price is positive and f of P are non-negative, both of them, and f prime P is negative because demand is usually a decreasing function of price. When the price is increasing, demands will be decreased. Okay, so A of P is negative, f of P is negative, so f of P is negative, f prime of P is negative, so E of P is non-negative. Okay, so when E of P between 0 and 1, so when the elasticity is between 0 and 1, it is called the inelastic. That means demand is not sensitive. Sensitive to change in price. That means, on the other hand, revenue increase when the price increase. So a price increase will increase revenue. And if elasticity of demand bigger than 1, that means demand is elastic. Maybe we should write here demand. This is situation of the E of P, elasticity of demand value. This is interpretation. And this is the behavior of the revenue. So, in that case, demand is sensitive. Is sensitive to change in price. And that means revenue decrease. So a price, okay, let's change the color, maybe you can, oops, sorry, or let's use that line. So a price increase will decrease revenue. And if elasticity equals 1, elasticity of demand equals 1, not 0, equals 1, that means demand is unit. So a percentage change in the price to produce the same percentage change in the demand. So a percentage change in price produce the same change. In demand. So revenue does not change, because the change of the price and the change of demand is same. So the product of the price and demand will be same. So there is no change in the revenue. So the revenue does not neither increase or decrease when a price increase.